Hello everyone, welcome back. After this lesson, that is for prediction.ipynb notebook, most of the students are getting this error. That is, when they're executing the real-time prediction and you might actually facing the issue, something like this, a setting of element in sequence, the requested array has inhomogeneous shape of one dimension. The detected shape was 7, plus inhomogeneous part. So basically what exactly is happening is that the shape that was actually found in the retrieve data frame and the features are inconsistent. So if you look into that, for example, if you call the retrieve data frame and facial features, now if you individually look into the each and every features in a for loop, let's say for xx and this, now print xx.shape. Now if you individually look into the shape of this, what happens is that the shape that whatever it was there, it is completely inconsistent. And because of completely inconsistent shape, that is 1024 is somewhere we have and 512 somewhere we have, and because of this we are actually facing this error. And moreover, the shape that whatever you're seeing 1024 is not an appropriate shape. The ideal shape that we have to save is 512 samples. Now let's look into the place that where exactly this error has occurred. Now in order to solve this issue, we have to go to the notebook, which is 3 save and retrieve data. So in this 3 save and retrieve data, let's execute all the lines one by one again. So first let's import all the libraries, and also we have to connect to the Redis client. Then use the r.ping and make sure that this is true. All right, now we have the connection is successful, and now the next step is we need to load the data. And once you load the data, and the immediate next step what you have to do is that let's look into the shape of the facial features. For that, let me type df of facial features. Now let's look into the individual facial features. Let's say for xx and df.facial features. Now let's print xx.shape. Now if you look here, and the shape is completely homogeneous, and moreover the shape that we're actually seeing is the 512, which is actually correct. And let's also look into the data type of it. So in order to look into the data type of it, we need to take the data, the xx.dtype. Now if you look into the data type of it, okay, let me do one thing. Let me put this and put comma, and after that, and put everything, both the information in the same print, and now this is what we're going to see. And what you have noticed is that the array that whatever you're seeing is an array, and it is an array, and it is a data type of float 64. And here is the problem is occurs. We always need to look into the data type of this array to be the float 32. Okay, so we are assuming the data type that to be the float 32. So make sure that the data type that whatever we are actually retrieving should be the float 32. So in order to do this, we can't directly do that. In order to do this, first of all, we need to take the df.facial features, which is equal to, now again call the df of facial features, okay, now dot apply. Now what you need to apply, take a lambda function x such that x dot, now we have to take the each and every individual array, and for each and every individual array we actually need to convert that into shape. As type is np dot float 32, and this is the very important step that we have to do, and because of this step that we have missed, it's causing the issue in the entirely in the next preceding notebook also. Now what you have to do is that we have to safely save this one or execute it, and once you have executed this, make sure you check this features once again. Let me copy and paste it below. Now let's execute this, and this is what the expected. The data type what we have seen is the 512. The shape is 512 and the data type is float 32. Once you're done, Now let's execute the next step, that is concatenating of the name and role, and done. And then let's look into the number of records. That what we see is the 5 records. I think we are good. Now let's save the database in the Redis. In order to save this data into the Redis, the first step what you have to do, since we already inserted some values into the academy colon register, what I'll do is that let me copy this and let me delete this hash set. So in order to delete this, r dot delete and provide the key or name of the key, which is the academy colon register. Now let's execute this, and this will delete the academy colon register hash set successfully. Okay, now make sure that you comment this, otherwise you accidentally delete it again whenever you're running it. All right, now I think we are good. Now what I'll do, let me save all the information into the academy colon register, and also look into the vector.dtype, which should be the float 32-bit. Now we are good. And next step what you have to do is we have to retrieve the records from the Redis, and for that I'm using the r.hsettle and academy colon register. And since the data that what you are seeing is the buffer, basically in the Unicode, and in order to convert that into the proper array, we have to use the np.fromBuffer, and then we can actually make sure that the data type is np.float32. Okay, now execute it and execute it and execute again. Now what you can see is that you can look into the, if you look into the individual shape of the facial retrieve, and this should be 512. And make sure that you can also run a loop and test it again. For example, for XX, and again the whatever the data that you have retrieved from the database, now you have to print the xx.shape and xx.dtype. So the expected value should be the 512 and float32 for each and every record. Done. Now we are good. Now let's go back to the registration form and register a new user. And for that I will import the CV2, import inside phase, and make sure you use the Buffalo SE model, and what are the model you want, you can keep on using that, and collect the samples. And we know how to do this. Okay, now let's collect the samples. I'm collecting some samples and all the directions. All right, now once you're done, and you can look into the number of embeddings that whatever we set is previously is 200. Now let's optimize and save the data. Basically whatever we had actually having the 200 samples, and from the 200 samples we need to actually take the mean out of it. Now let's take the mean, and also make sure that you need to check the data type of this x_mean.dtype, and this should be always float32. If it is not float32, if it is float64, convert that into float32. Now once you're good, and now you need to convert into bytes and then save that into this particular name, which is academy colon register, and done. So with this we have actually successfully saved the, basically we have actually repaired this. Now if you go to the predictions.py or IPynb notebook, if you execute this notebook once again, first we have to import the facerec and import pandas or all required libraries, and connect to the Redis using the facerec module. Now what you have to do is that you have to retrieve all the information, and make sure that whenever you're retrieving the information, and this is already there, I explained in the previous slide, but you have to double check that the data type should be np.float32. Let me execute this, and now we have successfully retrieved the data. And now let me look into the shape of each and every samples. So for that, for xxn, retrieve.facial features, print xx dot, and also it's most important to look in the data type of xx. So xx dot dtype, and this should be float32. Okay, and the shape should be the 512. execute it, and here you go. This is what we are expecting now. Next step is let's look into the real-time prediction, execute this, and hopefully this time this will work. Here you go. This is working perfectly fine now. Now hope you have actually solved this issue. If at all you are facing any issue, please post your question in the Q&A and we're going to reply you on that. Thank you very much.